Right, good morning, grade 11s. I hope you all managed to understand all the work that we did in yesterday's lesson, and that you understand about the structure, external, and a little bit about the internal structure of the human kidney. Now, I normally work with a mouse, and unfortunately the USB port on that side of my computer has just stopped working. So if I'm a little bit more clumsy with slide changing than I normally am, I apologize in advance. Right, let's go. So I'm presuming everything was okay with the external structure of the kidney. And then yesterday we started with the overall internal structure of the kidney. I'm just going to go through that again to make certain that you do understand it. So internally, the kidney has 3 regions, each approximately 1/3. And working from the outside inwards towards the hilum, in other words, from the convex surface towards the concave surface, they are directly inside the renal capsule is the renal cortex or cortex. Inside that is the renal medulla or just medulla. And then the innermost, approximately 1/3, is the renal pelvis. Now, the word pelvis means a basin-shaped structure. And so if you consider the pelvis of the pelvic girdle is also a basin-shaped structure. And so the renal pelvis is very similar. It's a hollow basin-shaped structure. Okay. Then the hilum is the concave inner part of the bean shape, where the blood vessels and nerves enter and exit the kidneys. And it's also the point of exit for the ureters. So let's try and work this out without having a mouse. Okay, so there's the renal capsule on the outside. Sorry guys, this is not that easy. I don't like using these touchpaddy things. Okay, so from there down to there is the renal cortex, and from there down to there, all the way around, is the renal medulla. And then the renal pelvis is this inside portion here, with the hilum being this concave section here. Okay. So the outer, okay, the outer reddish region underneath the capsule is the renal cortex. Is it gone? Okay, it keeps disappearing. Okay, renal medulla is from there to there, all the way around. And the renal medulla consists of a number of what are called renal pyramids. And so this structure here is one renal pyramid in the renal medulla. This is another renal pyramid in the renal medulla. Okay. The renal pyramids appear to be striated or striped. And the reason for that is because they contain the straight tubular structures of the nephrons and the blood vessels. And I will explain that to you in more detail later on, and hopefully it'll make more sense to you. Right, so remember, blood vessel bringing oxygenated blood, but high in nitrogenous waste substances into the kidney is the renal artery. Okay. Renal vein would be carrying deoxygenated, but fewer nitrogenous waste substances out of the kidney. And then the ureter, which transports urine from the renal pelvis down to the urinary bladder. Okay, you're happy with that? Ignore this renal sinus label here. That's not really critical for you. Then the only other thing that I have to remind you about is that the pyramid consists of many tubes down which they're very, very tiny, and urine is busy being transported down those little tubes. So the base of the pyramid always faces towards the cortex, and the apex of the pyramid leads into a little hollow structure called a calyx. Now, they're little calyces called minor calyces, and those join together and form greater calyces or major calyces. Some of the calyx regions don't have a major and minor, there's just one, and so don't worry about it. What is important though is that they surround, they're hollow, and the calyx then surrounds the ends of the little tubules of that make up the pyramids. I hope that makes sense to you. If you want to have a different picture in your head of how to picture them, let's say that you are holding a bundle of pencils in your hand, and your hand surrounds the parts of the pencils that have a point, that have the points. So you've got a bundle of pencils, and the points are in your hand down towards the palm of your hand. I hope that makes sense. And that is what these little structures are like. So the pyramid is made up of tiny, extremely tiny little tubes that I'll talk about later on. They are hollow. Urine travels down those little tubes. Urine goes into the calyx, and all the calyces join together and lead into the pelvis. Well, they don't join together. They just directly lead into the pelvis, which is the hollow basin-shaped structure. And the pelvis then continues down as the ureter. I hope that makes sense. If it doesn't, let me know via email, and I will sort out an ASP for you, or I will explain it to you again in more detail tomorrow. Okay, so the wide base of each pyramid faces towards the cortex, and the pointed apex of each pyramid, called the renal pillar, is directed towards the center of the calyx. So the base faces towards the cortex, the apex, called the renal papilla, faces in towards the calyx, and the apex of each pyramid is enclosed in a calyx, and the calyx is an extension of the renal pelvis. The calyces channel urine from the pyramids to the hollow renal pelvis. And this is what I was telling you yesterday when I said you need to watch the video of the kidney dissection. The lady was calling a calyx a collecting duct, and they're not the same thing, and I will explain in time what a collecting duct is. But you just need to know that that thing she was showing you, that white thing, was a calyx. Then the central region of the kidney contains a hollow basin-shaped renal pelvis. That renal pelvis narrows here, and it leads down into the ureter. So it's like a funnel, a filter funnel. And the renal pelvis is a large cavity into which urine passes as it goes through its final stages of production in each of the pyramids. And I'll explain that to you in more detail later on. So there you've got a longitudinal section of the kidney. This is probably a sheep's kidney. And what you can see is the calyx very clearly. So the calyx is, the cortex, not the calyx. It's very clearly from here to here. Okay. Then all of this region from there to there is the renal medulla. This is the renal pelvis. And so this is a calyx. And that means that this pyramid, the apex of this pyramid would go, this is fat, okay, would then pass into this calyx, which you can see is actually hollow. And then urine would pass down the tubes that form the pyramid, and they would go into the calyx. It would go into the calyx, urine would, and the calyces then each lead into the renal pelvis. So urine would pass down here, collect, and then go out the ureter, which has been detached from this dissection. And then this part here is the hilum. Okay. All right. Oh, I thought this was with yesterday's. Anyway, so there's the video. Be careful about the errors between minutes 4 and 5, where the lady calls a calyx a collecting duct. Okay. Now what we're going to talk about is we're going to talk about the functional unit of the kidney. So the kidney is made up of many thousands of tiny little structures called nephrons. There are thousands and thousands and thousands of little nephrons making up each kidney. And I'm going to explain it to you very superficially first. And I'm going to put it into context in terms of where it's situated, where a nephron is situated within the kidney. And then I'm going to come back and do a little bit more detail. And then I'm going to come back and do it in even more detail. So it might seem a bit disjointed and pointless at the moment, but it will make sense when I have put everything together. Okay, so just trust me on this one, and let's go through and talk about it. Okay, so what is a nephron? It's the functional unit of a kidney. It's the structure which makes urine. So what it does is it filters blood and it makes urine with the substances that are filtered out of blood, and then that urine then passes into the calyx and out it goes through the ureter. So the nephrons are tiny microscopic tubes. They're approximately 30 to 40 millimeters long, so that's about 4 centimeters, but they are in fact microscopic, even although they're quite long. Yeah, yes, that makes sense. And each nephron consists of a number of different regions, each of which has a different function. So if we have a look here on this particular drawing here, there are two main parts to a nephron. Okay, the first part is this little structure here, and that is called a renal corpuscle or a Malpighian body. Both of those terms are acceptable, and I'll show you that in writing now. So renal corpuscle or a Malpighian body. It's this little round structure. And this is the part that filters blood. So this is really very much like a funnel in the kitchen. You know, somebody in your household, I'm sure, uses funnels in the kitchen. And this is very similar to a funnel. This is the funnel-shaped part. And then this is the very long part down which everything passes once it has been filtered. Okay. The rest of this part of the funnel, this long part here, is called the renal tubule. So the two parts are the renal corpuscle or Malpighian body and the renal tubule. And the renal tubule has got lots of different regions to it, because filtering blood is not as simple as it appears to be. It's actually pretty complicated. And once the blood has been filtered and the liquid called filtrate passes through into the renal tubule, lots of things still happen to that filtrate as it passes down the tubule. And those things that happen in the different regions. So in one region this will happen, in the next region that will happen, etc., etc. And so it's a pretty long, pretty complicated structure. And I will go onto a slide after this and show you the various parts of the renal tubule. Okay, so let's have a look at it in context in the kidney. So look at the drawing. And this shows you highly magnified one nephron. actually in a kidney. So look at it over here. Now, this is flipped left to right in comparison to the drawing I showed you now. So if you look here, this little dot here is the renal corpuscle or Malpighian body. And then this is the tubule. And you can see it goes right down into the renal pyramid, and then it comes back into the cortex, and then it thickens and it goes down into the pyramid again and leads into a calyx. And I'll explain that to you in more detail just now. So look at the notes on the right-hand side. A nephron consists of two parts. A renal corpuscle, also called a Malpighian body. Now, Malpighian is named after some gentleman called Mr. Malpighi or Dr. Malpighi or whatever he was. I think he was a doctor. And then the second part, so because it's named after somebody, sorry, capital M, proper noun, named after somebody. And be careful, the H comes after this G. I know that very often the kids like to put the H there. In fact, I like to put the H there, but it's not correct. Okay, so a renal corpuscle, that little dot there, the part that acts as the filter, and then the renal tubule. And the renal tubule is the part in which the fine-tuning of what happens to urine occurs. And then closely associated with each of the nephrons is a capillary network, and I'll explain about the capillary network just now. So there are branches of the renal artery that branch within the capillary, the kidney, and one branch goes to each little nephron, and it goes through a whole lot of little divisions that we'll talk about just now. Okay. So, the renal corpuscle or Malpighian body, and be careful. Remember that the membrane around the outside is the renal capsule. So don't confuse renal capsule and renal corpuscle. They're two different things. That's why it might be easier if you just learn this word Malpighian body. Okay, so the renal corpuscle or Malpighian body is located in the renal cortex. And the renal tubule is a long structure that emerges from the glomerulus. So the glomerulus is part of the Malpighian body, and I'll explain that just now. This is wrong. This should read Malpighian body. I'm sorry, guys. Sorry. I will change that on the PowerPoint just now, but it's too late to change it with this. So presume that that word there should actually be Malpighian body. Okay, the renal tubule is convoluted. In other words, it's very windy in certain parts, and it's very straight in other parts. Part of each renal tubule is located in the cortex of the kidney, and the rest is located in the medulla. So let's have a look again. Malpighian body, or renal corpuscle, and then the rest is the renal tubule. So the Malpighian body lies in the cortex. The first part of the tubule also lies in the cortex. Then the tubule dives down and goes into a renal pyramid. It curves around and it comes back out of a renal pyramid in the medulla and goes back into the cortex. And then it joins together with a number of other little renal tubules from other nephrons. And so it's becoming bigger and bigger and bigger as it joins with more and more other nephrons. And it forms quite a big tube here. And that is in the pyramid, and that leads into the calyx. And this part is the collecting duct or collecting tubule. And when that lady was doing the dissection of the kidney and kept on referring to the collecting duct or collecting tubule, she was talking about the calyx, but in fact it is this tube that leads into the calyx. It's not part of the calyx, it's surrounded by a calyx. Okay, all right. Now I'm going to go back to this drawing because this is the nicest drawing of them all. Okay, so let's have a look at the parts of the renal corpuscle or the Malpighian body. If you look at the Malpighian body, it's made up of two parts. So I said to you that there's a branch of the renal artery that leads into the Malpighian corpuscle, and that is a very tiny artery called an arteriole, and it's called an afferent arteriole. Afferent always means leading in towards something. So here there's an afferent arteriole leading into the Malpighian body, and within the filter of the Malpighian body, it divides into many small capillaries, and those small capillaries are called the glomerulus. Those little capillaries then join together again and form a little blood vessel leaving called the, oh, I didn't label it, efferent arteriole. Sorry guys, I left off the label here. Efferent arteriole. Okay, and I'll talk more about that just now. So what I've said to you is that the renal corpuscle is made of the glomerulus, which is this knot of capillaries in the center here. And then it is surrounded by a double-walled filter-shaped structure called Bowman's capsule. Capital B because it's named after somebody, and in theory apostrophe S because it's named after somebody. Okay, so that's the Bowman's capsule. And Bowman's capsule plus glomerulus equals a renal corpuscle or Malpighian body. I hope that makes sense. Now, Bowman's capsule is a double-walled structure, and there's a space between the two layers of the wall. And we're just going to call that the space of Bowman's capsule or the lumen of Bowman's capsule. Okay, do the neighbors have to start drilling at this stage? We ask ourselves. Then, all leading from Bowman's capsule is the renal tubule. So everything from here on is renal tubule. Now what you will see is that the first part of the renal tubule is very windy. It is called the proximal convoluted tubule. Convoluted means windy, tubule means tubule, and proximal means close to. So it is close to the renal corpuscle, and that's why it's proximal. It is windy, that's why it's convoluted. And it's a tubule, that's why it's a tubule. Okay, so that's very windy. This only shows one wind. Okay, this is all in the cortex. Now what happens is the tubule enters the medulla, it enters the pyramid of the medulla, and it straightens and it forms a loop. And that loop is called the loop of Henle. Capital H because it's named after somebody. And in actual fact, it should have an accent grave, I think it is, on the E, an accent going that way, but they've stopped writing it like that, and so we're just going to call it a loop of Henle like this. And you can see that the loop of Henle is very straight, and it curves around, and then it goes back up again. Now it's going back towards the cortex, and it becomes convoluted again, but this portion, even although it's convoluted, is far away from the Malpighian body, and so it's distal, as in distant, but distal, convoluted because it's windy, tubule because it's a tubule, and so it's the distal convoluted tubule. And then what you can see is that a number of distal convoluted tubules join together, and so they're getting bigger and bigger and bigger, and this is called a collecting duct or a collecting tubule, or a term that used to be used quite a lot, but is very seldom used nowadays, but I see that your textbook has got it, is right at the bottom here, where a collecting duct or a collecting tubule is very big. It is sometimes called a duct of Bellini, and I've got that in one of the slides further on here. And Bellini is a proper noun, and so it's got a capital B. I hope you can't hear this drilling next door. Okay, right, so going back, revising. Okay, so there isn't a label here for renal corpuscle or Malpighian body. So the glomerulus is the capillary network in here. Remember, afferent arteriole bringing blood in. Capillary network is the glomerulus. All the capillaries join together and form the efferent arteriole leaving. Double-walled cup is Bowman's capsule with a capital B. And leaving from that is the tubule. First part, proximal convoluted tubule. And all of this is in the cortex. And then the proximal convoluted tubule goes into the medulla, into a pyramid of the medulla, and forms the straight loop of Henle, which loops around and comes back out again, and back into the cortex. And this then is the distal convoluted tubule. Distal because it's further away from the Malpighian body, convoluted because it's windy, and tubule. And distal convoluted tubules join with other distal convoluted tubules, and they become called the collecting duct. And they're getting big. The collecting duct is getting bigger and bigger as more and more of these things join together. And then you can see that the end of the collecting duct, which remember may be called the duct of Bellini, but I'm not obsessive about you knowing that term, leads directly into a calyx in medulla. Okay, so if you had to put a line across here, this would be cortex and this would be medulla. Okay, so you need to know that. What did I want to tell you at that point? Okay, right, so I'm just going to briefly go through how this thing works, and then I'm going to go back and talk about the more detailed structure later on. Okay, so let's go. Blood comes into the glomerulus via the afferent arteriole. For a whole lot of reasons, filtration occurs here. In other words, a whole lot of molecules that are small enough filter out of the blood vessels into the space of Bowman's capsule, and they form what is called the filtrate. Now, the filtrate then passes along this whole tubular thing. The problem is that first filtering process is simply on the basis of anything that is small enough filters through. And a whole lot of really important, very useful substances are small molecules and they filter through. And a whole lot of big toxic waste substances are too big and don't filter through and carry on in the bloodstream. Okay. And so because that is a very inefficient mechanism that happens here, no, it's not inefficient. It's just not. It hasn't separated the components of blood by toxic waste, need to get rid of, and useful, keep. It's separated the components of the blood according to size. And so a whole lot of useful things have filtered through here, and a whole lot of toxic things have remained behind in the blood. So the purpose of having this really long tubule here is simply to sort out the finer details of that. So as the filtrate moves down this tubule, everything that is small and filtered through but was still useful is reabsorbed from the walls, through the walls of the tubule, from the filtrate, and gets pushed back into the bloodstream. And everything that was big and toxic that remained behind in the bloodstream gets pushed from the bloodstream into the tubule. So as the filtrate moves down the renal tubule, there's going to be a two-way movement of substances. Useful stuff that is in the filtrate, please don't say stuff in a test or exam, that is in the filtrate passes from the filtrate into the blood, and I'll show you how now. And anything that is toxic in the blood passes from the blood into the tubule. So that this is happening as the filtrate moves further and further along here. It's getting more and more like urine and less like the filtrate that was filtered here. And by the time it reaches the end of the distal convoluted tubule and the collecting duct, it's no longer called filtrate, it's now called urine, because everything that needed to happen to it has happened to it. And so this is urine, leads into the calyx, leads into the pelvis, and then passes out through the ureter. Okay, does that make sense? So here's a nephron. There's the Malpighian corpuscle. This does the filtering. Filtrate goes into the proximal convoluted tubule, and it starts to be refined. Everything that is useful in the filtrate will be absorbed through the walls of the tubule and be put back into the blood, and everything that was toxic but remained in the blood will pass from the blood into the tubule, so that by the time the filtrate has reached, can you see that this then is the end of the distal convoluted tubule? And so by the time the filtrate is in the collecting duct, there's one final thing that has to happen to it that we'll talk about, but by the time it reaches the bottom here and goes into the calyx, it is urine. So can you put what you learned in the previous slides into place here? There's a Malpighian body, there's the proximal convoluted tubule, there's the loop of Henle, there's the distal convoluted tubule, and here's the collecting duct, and there's the duct of Bellini down at the bottom there. Okay, does that make sense? I hope it makes sense. Okay, all right. So this just puts everything down into text for you. So the first part of the renal tubule is called the proximal convoluted tubule. Something about the Malpighian body, okay. Oh, there's the glomerulus and the renal tubule, okay. All right, so the first part of the renal tubule is called the proximal convoluted tubule because of its proximity to the glomerulus. The second part is called the loop of Henle because it forms a loop with a part that is, the first part of the loop of Henle is called the descending limb of the loop of Henle because it's going down, and then the ascending limb going up. And then the third part of the renal tubule is the distal convoluted tubule, and many distal convoluted tubules join with and empty their filtrate into a collecting duct. Many collecting ducts form pyramids. So the collecting ducts from multiple nephrons join together, getting bigger and bigger and bigger and forming what are called ducts of Bellini. So this is a term seldom used in schools nowadays. You don't have to know it, but it is in your textbook. If you're going to use the term duct of Bellini, look at it, capital B, because it's named after somebody. Okay, right. So let's have a look at this. Here I showed you, if there's a line that you're going to draw to say this is the cortex, this is the medulla, then the Malpighian corpuscle, Malpighian body, renal corpuscle, proximal convoluted tubule, distal convoluted tubule, first part of the collecting duct are in the renal cortex, and then the loop of Henle and the major portion of the collecting duct. So they always just talk about the collecting duct or the collecting tubule being in the renal medulla. Okay, so those are in the medulla. Are you happy with the structure of the renal corpuscle? There is a slide with it in more detail, but it must be a little bit later on. And that's enough for one lesson. I hope you're okay, and if you needed to go over 2 lessons, let me know. Right, how do I end this now that I don't have a mouse?